Find the exact area of the surface obtained by rotating the given curve about the x-axis. So this is a problem that you might have seen or will see in your textbook. So this is, our curve is y equals 1 over x. Our endpoints, our x is between 1 and 2. 1 and 2 are included, as we can tell by the greater than or equal to sign. And this is what more or less your curve will look like rotated about the x-axis. This is y equals 1 over x from the points 1 to 2. Cut those off and then just rotate the curve, and that's what more or less you're gonna have to look, or you're gonna have your graph look like. So let's go ahead and solve this. So we're gonna use that the solution. Okay, solution. So we're gonna use the formula. S is equal to the integral of a to b of 2 pi y times the square root of 1 plus dy dx squared, square by the way, dx. So we're going to use that formula to solve this. So let's go ahead and solve this. Let's go ahead and plug in our values into the formula. So let's write it right here. So this is the integral of a. A is 1 and b is 2, right? From 1 to 2. 2 pi y. We have 2 pi. What's y? Y is 1/2, right? I mean 1/2, 1 over x, right? Times the integral of 1 plus. Now we're gonna have to find the derivative of 1 over x. So the derivative of 1 over x, let's see, x to the negative 1, you subtract 1, x to the negative 2, divide by that, I mean, yeah. Okay, so that's going to be, oh yeah, okay, that's going to be negative 1 over x squared, right? And this says to raise the derivative of dy dx, the derivative of y with respect to x, by 2. And that's what is that going to give us? That's going to give us 1 over 4, right? 1 over 4, sorry, 1 over x to the 4, yeah? So, oops, that's going to be 1 over x to the 4th power. That's a 4th power, right? Dx. Yeah, you could barely see that. So, yeah, integral of 1 to 2, you got 2 pi times 1 over x, square root of 1 plus 1 over x to the 4th power dx. Again, that's how we got the derivative. Let me go ahead and just erase our derivative real quick. All right, now let's go ahead and rewrite this. Remember, this here is a constant. And remember, we can pull constants out of the integral. So let's go ahead and pull out the constant out of the integral. Let's go ahead and do that. That is going to be 2 pi at the outside of the integral. Our integral is going to be 1 to 2 of 1 over x times square root of 1 plus 1 over x raised to the 4th power dx. Alright, so now we can go ahead and use u substitution for this. So let's go ahead and use u substitution. Actually, first let's rewrite this as something. Yeah, let's rewrite it. We are going to rewrite this as, again, 2 pi. Actually, who cares? All right, let's go ahead and do it. 2 pi of 1, and then we have 1 over x. Right, yeah. Times 1 plus 1 over x squared. That's a square, by the way, to the 2nd power dx. We should just leave it like that. We should have just left it like that. Yeah, we should have just left it like that. Now, look at this. 1 raised to the 2nd power is the same thing as 1, right? That's x to the squared power, right? 1 over x squared. That's what it is. So 1 raised to the 2 power is the same as 1, right? So we can rewrite it as that. So now we can go ahead and use our u substitution. we can let u equal what's inside this. So let's go ahead and let u equal that. So let's go ahead and use our u sub. U sub. Okay, u sub. So let u equal, what's u gonna equal? 1 over x to the 2, right? 1 over x squared, right? 1 over x squared. That means that our du equals dx. Let's multiply dx by the derivative of that. So let's go ahead and let's see what the derivative of that is. So we have x squared. I mean x negative squared. You take away you do this. So it's negative 2x minus 3. So that will be negative 2x3 x to the cube power. Okay, so that's gonna be the derivative of that. So now you're gonna multiply this by the derivative of that. Okay, so now you divide dx by this to leave dx by itself. We want to leave dx by itself. So let's go ahead and do that. So that is going to be x cubed is going to be right here, and x, oops, sorry about that, negative 2 is going to be at the bottom. So that is what our dx is going to be. So as you can see, dx is equal to du, that's u by the way, du times x raised to the third power divided by negative 2. So now we can go ahead and use our u substitution into our integral. So this is our new integral now. We have 2 pi. Yep, 2 pi. The integral of 1 to 2 of 1 over x, right? Times 1 raised to the second power plus u squared, right? U is 1 over x2 squared, yeah. U squared dx, I mean du. Du over x to the third power negative divided by negative 2. Okay, so remember, we can pull out the constant from the integral. So we're going to be pulling out a negative 2, right? So let's go ahead and pull out this and right here. Put it right here. So we're going to pull out a, not a negative 2, but a 1 over negative 2, right? We're going to pull this out of the integral. Yeah, you get the idea. We're going to basically just pull this thing out of the integral. And you know what that's going to do? This is going to cancel this, and this will leave us with negative pi, right? Because we pulled out the 1 over negative 2 outside of the integral, so it's going to leave us with negative pi. Negative pi evaluated from 2 to 1. 1 over x. 1 squared plus u squared du x raised to the third power, right? Now look at this. We have an x raised to the third power in the numerator, right? And we have an x in the denominator. That is going to cancel each other out. So these two will cancel each other out. We're going to be left with an x squared. This is going to be gone. So let's go ahead and rewrite our integral as, let's see. We got negative pi. Integral from 2 to 1 of x squared. Remember, x squared, because look what we did. There's an x right here at the bottom. There's an x at the top. Cancel, cancel. That will give us x squared. X squared over 1 squared plus u squared du. Look at that. But there's a problem. We have a u here. We have an x squared there. We do not want this in terms of x. We want it in terms of u. So let's turn this into a u. Recall that u is equal to x raised to the negative second power, right? Where did we say that? We basically just said it here, yeah. This is basically equal to x raised to the negative second power. So that's what u is equal to. Now, this is an x squared. Look at this. X squared raised to negative 1 power. Does this not equal to x negative 2, which equals to u? Does that not equal to that? Yeah, it equals to that, to this, right? So when we raise this to negative 1 power, we multiply these two together. That's going to give us x raised to negative 2 power. And x raised to negative 2 power, like we established, is equal to u. Now look at that. That's a relationship where we are going to use. So let's go ahead and use this relationship into this integral. So this gives us negative pi integral of from 1 to 2, 2 to 1, I mean from 1 to 2, u to the negative 1 power, 1 squared plus u squared du. All right, now we have it in u notation. One thing that I forgot to mention is that this can actually be done using a formula, but I am not gonna go look for the formula in the table of integrals at the back of your textbook. And I also want to show you how to do this the long way so you guys can better understand. Because I like this. This actually uses like trig substitution and u substitution and that stuff. So I need you guys to learn that better than just like plugging stuff into the formula. Because if you know how to do this, like a complicated integral, kind of like this one, you'll feel a little bit more confident evaluating integrals without just plugging stuff into a formula. So I'm just gonna use this. By the way, I don't really have that formula memorized, so I'm just going to use the long way. So yeah, now we have this. Does this look familiar to you? 1 squared plus u squared. That is right. We are going to use trig substitution. So now let's go ahead and use our trig sub. So our trig sub. If you don't remember your trig sub, that's all right. Just look at your table of trig sub. It should be somewhere in your textbook. Any calculus textbook should have it. So, but let's go ahead and use some trig sub. So look at this, 1 squared plus u squared, that is going to give us, we are going to use trig sub. So actually I'll write it right here. Let u equal to tan theta, tangent theta. Now, our du is going to equal to d theta times the derivative of tangent theta, which is, what is it? It's secant squared theta. That is the derivative of tangent theta, secant squared theta. So that's what we got so far. All right, so let's go ahead and do this now. So let's go ahead and use our trig sub. So this is going to be negative pi, 1, evaluated from 1 to 2, of 1 over tan theta, right? This is basically 1 over u, 1 over tan theta. And we're letting u equal tan theta. Remember, let u equal tan theta, trig sub, square root of 1 squared. Actually, let's just leave it as 1, because 1 squared is equal to 1 anyways, plus tan squared theta. Right? du equals d theta secant squared theta. Now it's just about evaluating this trigs like a trig sub. So recall, I'm just gonna write this here, the square root of tan of this one. So 1 plus tan theta, what is that? 1 plus tan theta is secant squared theta, right? Though that is your Pythagorean theorem identities from trigonometry. So you should pretty much just have those memorized by now. And if you don't, just please do it. So we have 1 plus tan squared theta, square root. Actually, 1 plus tan squared theta is secant squared theta. Square root that's just going to give us secant theta, right? Secant theta. Okay. So, yeah, let me just... Who cares? Okay, secant theta. So now that we know that this is equal to this, which is equal to secant theta, now let's go ahead and rewrite this integral as negative pi integral of 1 to 2 of actually I'll do that later. 1 over tan of tan theta, right? Times secant theta. Secant theta d theta secant squared theta. Right, that's what we have. Okay, let's go ahead and rewrite this in terms of sine and cosines in this one as well. Yeah, let's go ahead and do that. So this gives us, rewrite the integral as negative pi integral of 1 to 2. Remember, tangent is sine over cosine, right? But since we're taking the reciprocal, it's actually going to be cosine over sine, right? So remember that. We have cosine. This is also equal to cotangent, by the way. Cosine over sine. And cotangent is also equal to cosine over sine. Secant is 1 over cosine times 1 over cosine theta. And then we again we have the d theta secant squared theta. We have that, right? And let me just go ahead and get my red pen. All right, I have my red pen. Look at this. We have a cosine here. We have a cosine there. You know what that happens? Yeah, that looks pretty bad, but they get canceled. So let me go ahead and put my red pen away. Since these guys got canceled, what does this give us? What's 1 over sine? That is cosecant. Yeah, 1 over sine is cosecant. So let's go ahead and rewrite the integral. Negative pi 2 to 1 cosecant. 1 over sine is cosecant. Oops, cosecant. Yeah, cosecant. Cosecant theta times secant squared theta d theta, right? That over here. So now that we have this integral, we can go ahead and rewrite the secant theta in terms of 1 plus tangent squared theta. So let's go ahead and do that. We have negative pi integral of 1 to 2. We're rewriting this integral so many times, but this is a long way because I don't really have that formula memorized right now, and I don't really want to go look for it. And this is better to sharpen up your integral skills. Times 1 plus, remember, this is equal to this, remember that. 1 plus tan squared theta d theta. So now we're going to use the distributive property to distribute cosecant around. Again, let's go ahead and rewrite this integral. We have a negative pi integral of 1 to 2 cosecant times 1, that's cosecant theta plus, that does not say 0, that's a theta, plus cosecant times tan squared theta. Cosecant times tan squared theta d theta. Actually, let me put parentheses. D theta. Right? Alright, now this can be, again, rewritten. Look at how much work we did. We rewritten as negative pi. We can rewrite this as two integrals. 1 to 2. Cosecant theta. Right? Plus, let's go ahead and put parentheses, plus the integral of 1 to 2 of a cosecant tan squared theta. D theta. I forgot the d theta. I'm sorry. D theta. I hope you can see that's d theta. And then we have the d theta here. You know what? That looks pretty bad. D theta. Okay, I'm just gonna read it to you because that actually looks pretty bad. Negative pi parentheses, integral from 1 to 2 cosecant d theta plus 1 to 2 cosecant tan squared theta d theta, close parentheses. So basically we're just distributing the pi all over. So this gives us two integrals. So let's go ahead and solve these two integrals. Let's go ahead and first solve this one. Yeah, let's go ahead and first solve that one. So we have the integral of 1 to 2. Yeah, let's save this one for later, the pi of cosecant squared theta. Cosecant, let's go ahead and rewrite cosecant as 1 over sine. 1 over sine theta times tan squared theta sine squared theta over cosine squared theta. Okay, now let's go ahead and cancel. Let me get my red pen. All right, so now I cancel this thing out. So this gives us 1, 2. Basically this thing gives us because we canceled one sine. So this just gives us sine theta because we canceled one sine from the numerator and one sine from the denominator. So this gives us sine theta. This can be rewritten as cosine theta times cosine theta. Right? Yeah. Oh, for the d theta, I'm sorry about that. D theta. Okay. So this can be rewritten as let's see, sine over cosine, that's tangent. 1 over cosine, that's secant. This can be rewritten as 1 to 2. That's 2 tangent theta, right? Plus sec 1 over cosine secant theta. Remember, sine over cosine tangent times 1 over cosine secant theta. D theta. Does this look familiar to you? The antiderivative of tan theta times secant theta is going to be secant theta. So this here is just going to be equal to secant theta evaluated at 1 to 2. So we're done with this integral. Let's go ahead and solve this one right here, this one. Okay, so let's go ahead and do this one. So we have the integral of 1 to 2 of cosecant d theta. So the integral of cosecant d theta already has an integral that you should already have memorized. So let me go ahead and do that one. So this is going to give us that's going to give us negative ln natural log cosecant theta plus cotangent theta. Natural log, absolute value, sorry, evaluated at 1 to 2. All right, so let's go ahead and combine these two. Remember, we have the negative pi, always remember that, times negative natural log of a cosecant theta plus cotangent theta, close that one, plus secant theta evaluated at 1 to 2, close parentheses. That's a 1. Yeah, that's a 1. 1 to 2, close parentheses. So that is what we have so far. So, but we cannot just leave it like that. We cannot just plug these into there and get the answer. No. Remember, we did trig substitution. So what does that mean? we are gonna have to substitute these trigonometric functions with the values given by the triangle, the triangle we use to do this. So I'm gonna have to use a different color. I'm gonna show you the triangle. All right, so I came back and I drew the triangle in red. So let me explain the triangle real quick. So remember we said that let u equals tangent of let u equals tangent theta when we use trig sub right here. So we said let u equals tan theta, remember. And what did we say that u was? U was 1 over x squared, right? It says right there. So since this piece is equal to u, because tangent is equal, you use your SOHCAHTOA from I don't know, high school or whatever, wherever you learned it. So SOHCAHTOA. Tangent is opposite over adjacent, right? So opposite of theta is going to be 1 over x squared over adjacent, which is 1. 1 over x squared divided by 1 is just going to be 1 over x squared, which is u, which is basically what we wanted to say right here. Tan is equal to u. So now we said what tan is equal to. Cotangent. Cotangent is basically just the opposite of, well, the reciprocal of tangent theta. So the reciprocal of this is just going to be x squared, right? We already found out cotangent. Secant theta. Secant is the opposite of cosine. So it's hypotenuse over adjacent, which is going to be, the hypotenuse is 1 plus x to the x to the 1 divided by x to the, okay, so it's square root of 1 plus 1 divided by x to the 4th power. We got that by using the Pythagorean theorem, a squared plus b squared equals c squared square root. So that's how we got that. So that's going to be your secant theta. Cosecant is just going to be hypotenuse over, what is that? Opposite. That's going to be x squared times 1 plus 1 divided by x to the 4th power. Remember, hypotenuse is going to be this divided by this. This, remember, just do some algebra and you're going to get that. So let's go ahead and continue with the problem. So now that I got my blue pen, let's go ahead and substitute these values into our integral thing here. So this is going to be, it's going to substitute it right here. Negative pi, and this is probably gonna give us some, oof, we're not gonna have room. Okay, that's okay. Negative pi, we're just gonna do that. So this goes with this, by the way. Negative pi, negative ln, natural log of cosecant, did I say, oh yeah, cosecant, x squared, the square root of 1 plus 1 to the x divided by x to the 4th power, plus cotangent theta. Cotangent is going to be x squared. Plus secant theta. Secant theta, what is secant? It's that 1 plus 1 x to the 4th power, 1 over x to the 4th power, close parentheses. So this is what we're left with, right? Let me check my notes real quick. Let me see. It looks like we're correct. Evaluated at 2 to 1. That's a 1, by the way. So now it's just a matter of plugging all of this in there. So let's go ahead and do that. Negative pi times negative ln x squared, that's 4. I mean x squared. We're going to plug in 2 first. X squared, 2 squared, that's 4. Times the square root. Oof. 1 over x to the 4th. That's 1 over 64 plus 1. That is going to give us... What is that going to give us? That is going to give us... you simplify everything, you're going to get root 17 over 4. So you simplify everything. You can plug this into your calculator. You're going to get root 17 over 4 plus 2 squared. That's 4, right? Plus that thing, which again is probably going to give you root 17 over 4. Let me just put some, so yeah, that, because this thing is going to distribute over everything. So actually, let me check if I'm right. I think I am though, but yes, I am right. Okay, minus, oof, minus. Actually, when we distribute the minus sign, that's going to give us a positive natural log. So, but let's just keep it like that. Yeah. Actually, let's. Okay, so that's gonna be a minus. That's gonna be a positive. Let's do. I have not done this, so let's. Hopefully, this works. I'm deviating from my notes right now because I kind of did it the first time I did it a different way. So plus ln minus ln of. Now we're plugging in a 1. 1 times root. Yeah, 1 times root 2. It's just root 2. 1 plus 1 over 1 to the 4th, that's 2. Root 2. Plus 1. 1 to 8 plus 1. Okay, that's gotta be it. We distribute the minus. That is gonna be root 2. Okay. Alright, so now I think I'm up to something. Let's go ahead and simplify this one. And let's distribute the negative pi, because your textbook wants it in a certain form. So I'm gonna try and match it to that certain form. I mean, if you're looking at this video for the textbook answer, then I'm gonna try and put it in that answer because I kind of know. I think I know what answer the book wants. Your book wants whichever book you're using. So okay, so ln. Cancel, these two cancel, so that's going to be root 17 plus 4 plus, yeah, root 17 over 4. I hope this thing actually works. Oh wait, no, we have a pi. I'm distributing the pi. Plus, oh wait, no, it's a negative pi. Negative pi root 17 over 4. Yes. Plus, oh wait, no, that's a negative pi, I'm sorry. Negative pi ln 2 plus 1 ln plus pi negative 2. Okay, so now we are going to factor out. I know this sounds weird because we already distributed. We're going to factor out a positive pi. So let's go ahead and factor out a positive pi. We're almost done. I know it is like 33 minutes, but okay, so it's going to give us negative ln. You know, actually, I don't think that would. No, I'm sorry. Positive pi, that's ln root 17 plus 4 minus, factor out the positive pi, 17 over 4 minus natural log root 2 plus 1 plus root 2. Let me check real quick if this is correct first. So this is where the textbook wants it in some weird format. So I'm going to go ahead. So what I'm going to do is I am going to multiply this thing, the outside pi, by 1 over 4. So that's going to give us 1 over 4 pi. And then what I'm going to do is I'm going to multiply all of this by 4. Right? 4. That gives us 4 ln root 17 plus 4 close parentheses, minus, you multiply 4 by this, it's just going to give you negative 17, negative root 17, minus 4 ln natural log of root 2 plus 1 plus 4 root 2. Sorry about that. Close parentheses. Let me see if that's the one that your textbook wants. Nah, one. Hold on. So this is the answer that your textbook wants. So overall, this is your final answer. That's it. So the textbook that I was using wants it in this format. So I gave you the format and I showed you how to do the format. So after we are finally done with all of this, after all that work, just for that, without using the formula. So I showed you the long way now. So now this combines a lot of integral skills. So now you can go ahead and use them. So yeah, that's it. That is it. If you stuck all the way to the end, thank you. And yep, I hope this helps, even though this is the long way. But if you do the long way, you're going to gain more confidence in your integrals.